Landon, you said that. All right. So what really happened was Zeke did about the first 15 moves and got bored because it's chess, and he's 4. And then I stepped in and was not like, I'm not good at chess. I'm not. I should be, and I will be hopefully eventually, but I'm not now. Wound up having a chance to beat Lando in class that day or that afternoon, evening. But we stalemated because I moved and he couldn't. So Zeke and Landon tied is the end of that story. Cool. Yeah, like it was a straight up tie, stalemate. All right, we were doing examples yesterday. Can you tell me the last example that we worked? Also, those are my true feelings about Abijah and Basil. Yeah, the chess stuff. That makes sense. All right. What letter is it, first of all? Oh, okay. It's probably solve. That's my guess.
Yes.
And what was the equation?
2
2 times 5 to the x
32.
equals 32. Did we finish this problem? Yeah. Okay. Remember in Algebra 1, when you first, or middle school, I don't care. Remember when you first started solving variables or 4 variables. You always wanted to isolate, right? Like that's been the rule all along. And it turns out it's still the rule here. It'll still be the rule when we have really ugly, gross, terrible looking things in calculus. It's all isolate the x, and it's just the algebra to get there. So as a quick review, just talking through this one, at the end of class yesterday, we worked this problem seemingly. Or at the start. I don't remember when we did it. But I bet we divided each side by 2. And then we had 5 to the power of x equals 32. And now it's all coming back. 16 is a better answer. Okay. And then we said in class, if you wanted to undo an exponential with base 5, you could take the logarithm with base 5, or there's another answer that doesn't fit as nicely into that schema, but it works just as well. Natural log. I'm going to take the natural log of this whole side. I'm going to take the natural log of this whole side. On this, I get x ln 5 when I use my power property. And I get the natural log of 16 here. And this question is going to keep showing up. This, and this also, but I only care about this one right now, is just a what? So I'm glad we're asking this question again. ln 5 is just a number. Now, do you guys think it's a nice number or an ugly number? Just written like that. Ugly. Okay, so you, of course, would rather I write this. Okay, so, and this is the weird part. Like, this is kind of, like, it does equal an ugly number. You are correct about that. But, like, this is strange, and I get that. But the alternative is doing this. Can we just commit to this? The other weird thing that just happens here is when we say it's just a number, just to think back to stuff that we've done, this looks normal to you, I think. Okay? This probably does not look normal to you. But is it any more right or wrong? No, they're the same thing, right? Multiplication is commutative, which means I can move it. Doesn't matter the order. But this feels wonky. Now, when we do square roots, and I know we haven't done a bunch in here, if I had the square root of 4, and I'm just going to do 2x squared. Let's say it was this. Do we all agree that we write it like this, typically? And some of you in here, do I accept it if you write it like this? Which of these do I prefer? So, top or bottom here? Which one do you prefer? Is it okay if it's the bottom? Yeah, but my issue and my concern for you is that if this line stretches out any further, then this is all of a sudden wrong and you're going to confuse yourself. Is this correct? ln 5 times x. And that, for me, for whatever reason, it feels wrong, even though it's more similar to this. Whether I write it here or here doesn't really matter. It's just a number in either situation. And it depends on what way we're writing that number to whether or not it feels like a good way to write it or not. If you look at this and you hate that like you're going to forget that that's a number every time, because every time I ask that question, the correct answer is a number. Like that's all this ever is going to be. You can rearrange it. You will never see me do it, but it's okay if you do. Cool. I don't know if anybody was rewriting it all the time, but I just want to make sure that was there. All right. We only did one example yesterday. K? Wait, what? Correct? Why would I say K? Strange. All right, let's do another one. Let's get loggy. No. I'm feeling loggy. All right. I don't really like it either, just for the record. Here we go. I want you guys to help me solve the following. I usually try to do different ones. Here we go. 7 times 5 to the wonderful power of 3t minus 4. That is all the exponent. But don't worry, that's kind of ugly. We're going to go ahead and add 1 to that side. And it is all equal in the end to 15. Love it. I'm going to take it back. Love, live, and laugh. Let's do it. I'm stuck. That seems pretty natural. You guys agree with that as a suggestion?
Yeah.
Yeah, let's subtract 1 from both sides of this equation. Now, you might do multiple steps in one, and I'm good with that. I think this is what I get.
Yeah.
Dolan, is this the exact same work that you did, or did you combine multiple steps?
I did that.
Okay. Is there an obvious thing that we could have done to combine 2 steps into one, Davian? Yeah, I could have just subtracted 1 and divided by 7 if you're comfortable in saying 14 divided by 7, but we can do it here all the same. So we get 5 to the power of 3t minus 4 equals 2. Now, just real quick, we should check. 5 to what power is 2? Okay, me too, also. Can't do it. Well, gosh darn it, I'm trying to solve for t. Where's it stuck? Say that again.
Exponent.
The exponent. How do you get something unstuck, a variable unstuck from an exponent? Log. Which base should we use?
5.
You could use 5. I'm not going to use 5. I'm not going to use 2.
I thought you had to use the number that was.
Nope, change of base says it doesn't matter what we use in the end. Log base 5 would work nicely, or log base 2 would work nicely because you're going to get a 1 out of the deal. But if I don't have to calculate it, or if I'm going to use my calculator to calculate it anyway, I would rather just save the time with the writing and just type in the ln button one more time on my calculator. I'm going to really, really specifically make this comment if you need it. We need to log, or to take the log is really what it is, take the log logarithm of both sides. Now, here's the bigger part. If you don't need to write this like I think that everybody is, it would seem, we need to take the log of both sides. When we do this, I'm going to make this a semicolon. Only thing that I care about. Same base. Now, I want to be very clear. I don't care about the base here because I can't make the same base. I don't care if it's a 5 or a 2. Same base with each log or for each log. Now, 5 would be a pretty good choice. 2 would be a pretty good choice. But if I'm given the choice, because I do get to pick, I'm always going to default immediately to the one that's fastest and easiest to write. You will never see me write log base 5 in a problem unless I'm told I have to. I'm going to ln every single time. Okay, I'm now going to take the natural log of both sides. So I'm going to use base e. If you are not quite sure, here's my suggestion. Should we split it up? Should we do, I'll do e, and you guys do 2, and you guys do 5, and see if we get the same thing? I assume that you kind of guess we'll get the same thing. Do we all want to use ln? Do we want to verify that we get the same answer and it doesn't matter? Okay, I'm going to use ln. Yeah. Okay, here's where I'm concerned about. I'm going to take the natural log of both sides, and I'm just going to add it here. ln and ln. So I've done the same thing to both sides of an equation, which algebra says I can do. Here's the part where I'm worried. What am I going to write here? Red, we made some eye contact there. Okay, I want you guys to criticize me mercilessly. I've made a mistake. I want you guys quietly first. I want you to think about it for about 10 seconds. Before we just do this, here's the deal. We have 2, 4, 6, 8, 10 people. When I'm done talking, I'll give you 10 seconds to think. You're going to play rock, paper, scissors with one person in class. Best out of 1. Whoever wins rock, paper, scissors either gets to pick if they're going to say to their partner, the loser in this situation, what was wrong, or if they're going to make the teammate tell. Okay, 10 seconds. You're going to think about it. Don't do rock, paper, scissors yet. You guys might have answers because you've probably been thinking as I was doing it. With somebody in class, you're going to play rock, paper, scissors, and the winner gets to pick whether you're going to tell me what my mistake is or if your neighbor is.
First out of 3.
No, it's just one. Straight up. All right, so Dolan gets to pick. What did I do wrong? So what was the entire exponent?
No, I won, you big.
Which means the entire exponent should go out front.
I don't know what it is.
What I've written, what multiplies? What's the power? If we were to condense this again,
Oh, okay.
what becomes the exponent with the way I've written it? Or in a different way to word this, because maybe that person didn't click. What is the only thing that's truly connected to the natural log of 5 when I write this? It's just the 4, right? This would be 5 to the 4th. If we don't include our parentheses here, we're done for. We need those parentheses. Otherwise, my 5 gets the wrong exponent if I were to condense it back down. Okay. Now, at this point, there are two options. I'm just trying to solve for t, right? I just need to isolate. Is there an obvious distribution that I could do? Like there's a very clear distribution available, right? Should we do it? You say yes, Dolan. I'm going to argue against you. If I distribute,
Oh, no.
I'm just going to have to divide by ln 5 again in a minute anyway. Could I just divide both sides by the natural log of 5 here and avoid the distribution? Yeah. I'm going to divide by ln 5, and really important, everybody should be able to answer this. What? That's a weird letter. Everybody should be able to answer this right away. What's the natural log of 5? So you're right, let me rephrase that. The natural log of 5 is just, it's a number. Like, it's just a number. Let's divide by that number. They go on this side. I'm left with 3t minus 4 equals the natural log of 2 minus the natural log of 5. Okay, I'm going to make a very intentional mistake. This is the correct thing that we should have. I am expecting somebody in here, if I don't work these problems with you or when you do problems like this on your homework, somebody is going to have this. It doesn't work. If we're going to divide in the argument, if I want to be able to divide, if I wanted to divide in the argument, I wouldn't divide by ln 5. I would have to have had what? What would allow me to, we would have to subtract. This doesn't work. Okay, so the correct answer was what we had there first, the natural log of 2 over the natural log of 5. Now, it's at this point that if we had chosen base 5 or base 2, we would see it, because I'm not going to work the whole problem the other way, but if we had chosen a different base, we would simply have log base 5 of 2 written here. This is the change of base, and it's how it shows up as ln. If we would have to change base anyway to calculate it, let's just do it from the get-go and use ln and save all that writing. Okay, 2 steps away, but I think we can do them in 1. How do I solve this for t? I'm going to add 4 and also divide by 3. Now, because of the way that it's written, I'm not going to divide by 3. I'm going to think about it differently. I'm going to multiply by 1/3. So I don't have fractions with fractions. Here's my plus 4. And then I multiplied both sides by 1/3. Now, the weird part about these problems is that there's a ton of variation that could show up if you wanted to keep going. Like, if you're not sure when you're done, I would say first, we've solved for t. I would stop here. There's nothing left to do. But, like, we could do all sorts of weird stuff that would make it look wildly different. I don't want to, but could we distribute that 1/3 to both of these? And then if I did distribute that 1/3 to both of them, and I'm just going to clear this. This is the right answer. I wouldn't encourage you to write anything else that I'm doing here. What? But this would be over 3 here then, right? If I distributed the 1/3, and there'd be a 1/3 here. So it's certainly possible that somebody looks at this, and then their next line, if they didn't realize they're done, they had the natural log of 2 over the natural log of 125, and all of a sudden we get numbers that didn't show up before, but they're mathematically valid. You're just doing more than you need to. Like, I would stop as soon as you have it solved. if we needed an exact answer, sorry, an approximate answer, how would we get it? What did you say? Because I think I heard it. I heard at least one consonant. Calculator, yes. Cool. All right. These things, are they okay? There's one more flavor of problem that I want us to taste, if you will. All right. I'm naming a new example. These are only different because we're here. We are solve a quadratic type. Now, these are quadratic type problems. And I want to remind us of something. When we factor, and we go through our whole big ugly factoring checklist, which we're about to do some factoring, just a heads up. When we factor stuff, I don't really care if it's x squared plus 2x plus whatever, right? And I'm just going to write different stuff. It could be ax squared plus bx plus c. That's a pretty common way to write a quadratic. We could use grouping or completing the square or whatever technique we want out of our checklist, right? What if I did this? Is this still kind of like a quadratic? Like, different problem. There's one. How could I rewrite this to convince everybody that it is a quadratic? Is this ax squared plus bx squared, and I'll just write to the 1 here and here, plus c? Does it still look like square and 1? Like, it does the same thing, right? We can always factor anything, and if you check your factoring checklist and you look closely, what you'll see is I don't say here's how to factor quadratics. I say here's how to factor things that take the form ax to the 2n plus bx to the n plus c, so that I guarantee that I can make this thing look like a quadratic of some type. I can always make this biggest power twice as big if it's this format. Okay, with that in mind, I'm getting some faces that go like, what on earth are you talking about? But I promise we're going to see it right here, right now. I need your help in solving the following. E to the 2x minus 7e to the x plus 12 equals 0. All right. What emotion do you feel when you first see this problem? Is it closer to joy or closer to pain?
Pain.
Okay. Why? It looks awful, right? Now, if it didn't have E in it, would it look as bad, do you think? Let's find out. Can I make this look like something squared, just right off the bat? So my goal right now, and we're going to rewrite this. So let's rewrite it. Nothing changes other than the way it looks, but we're going to say let's glow this thing up, if you will. We're going to rewrite it to look nice, and it will look nice. I assure you it'll look really nice compared to what it does now. Okay, e to the 2x. Well, is there some way that I could rewrite this so it looks like a quadratic? Something squared. If I do e to the x, it's squared, right? Okay, so that might not look nice yet, but it will in a second. Minus 7, and I'm just going to do the same. I could just do e to the x here, plus 12. Now, it doesn't probably look that nice to you yet. Do you agree with that? Does it look any better to you? It really does to me, but it might not to you, and that's okay. But here's the cool thing that we can do. I would not encourage you to always do this, but it's a really convenient trick. There are times in calculus where we will always do something like this, but here's what I want. This is ugly, still kind of. Whether or not you think it looks better is totally subjective, but we have this fancy magical word in mathematics that lets us go from something that looks awful to really nice. I'm going to use the word let. And specifically, what about this one makes it suck? I think we can probably all agree. Is it the 12? No. Is it the square? So real quickly, let's just check, because I think we all probably had this answer, like, ready to fire. What is the ugly part? It's e to the x, right? Check this. What if I just, for temporarily, I said, let's don't write it. Let's let u equal e to the x. Now, if I do this, and I can only do it if I physically write this magic 3-letter word, but we can substitute and use placeholders. We just have to put it back at the end. So let's try it. If I rewrite this, instead of, I'm just going to use my parentheses, something squared still, minus 7 times something plus 12 is still 0. Instead of e to the x, because that's the part that we're all like bummed out about, what can I call it? U. U squared minus 7u plus 12. Does this look like as bad of a problem? Is it any different? No, we're just using a substitution to say, hey, I don't want to look ugly. Well, here we are. Do my parentheses really matter here? No. Like, I can rewrite this even one step nicer, and I wouldn't usually take this many steps to do it. But I have simply u squared minus 7u plus 12 is 0. How on earth do we solve a quadratic that's already set equal to 0? We factor. What's the first thing that we always check? F in factoring. Fernandez. G. So you're jumping ahead. I agree with you. You skipped over GCF, but I very much possible, or what? I think it's possible you just did it and you didn't have a reason to write it. Okay. I'm going to jump right to leading coefficient of 1. And what happens with the leading coefficient of 1, Matilda? I don't want to misread, but I think that you might be lost for words. Why do I care? How do I factor? Okay, there we go. What is it? I now need, and I'm going to make you guys, at least in this one, you're going to factor like me for this. Somebody who doesn't factor, like, try my way. Like, Red and Casey are who I'm making eye contact with. You can do your way every other time, but I want you to try my way. Cool. What do I need? I have a 12, so what? Two numbers that multiply to be 12 but add up to negative 7. So they probably both have to be positive or negative. They're both negative. Now, you guys already have the number, I'm sure of it, but just in case somebody struggles, I'm going to start. It's not these. It ain't those, but it is these. Okay. The shortcut doesn't matter whether you're using my method or the other method that you guys use. I don't know what it's called. The fact that this is a 1 saves the day. It's so easy. If I know my magic numbers, whatever my first part of FOIL is, I know it's going to give me a 1u squared, so it has to be u and u, right? Like minus 3 and minus 4 equals 0 still. Are we done? No. It's at this point, and we're not going to have homework tonight, just so you know. We could, but we won't. It's at this point that I would do 2 steps in 1. U was just a convenient placeholder to not be as ugly. I could physically rewrite it as such, but I'm going to do one more step than this. This is what we really have. We had U as a placeholder. This is really what we could change to, but I'm going to show you how I typically approach these. I know that I'm going to have to set this factor equal to what? So if I already have this, I'm going to pretend like I didn't yet. If I already know that this is going to set equal to 0, I think I can add 3 and resubstitute e to the x in at the same time. So I erased that line just to show you that we could do it without it. But if I set this factor equal to 0, this is what I wind up with. And how do you get the x out of the exponent? Yeah, let's take the log. I would take the natural log of this side. It gives me x ln e equals ln 3. And x is the natural log of 3. We'll continue here tomorrow. You guys have a wonderful afternoon. Volleyballers, if you're watching this today on Thursday, good luck this evening. We'll all be cheering. Peace out, A-Town.